Good afternoon, students. Today in this video we will be discussing about molecular orbital theory and its postulates, right? So before getting to the theory directly and postulates directly, we should know what is molecule and how it is undergoing the formation of molecular orbital. So we normally know when two atoms undergo combination we get molecule. Therefore when one atom combines with another atom we get molecule. Likewise, every atom will have its own orbital, so therefore we call it as atomic orbital plus another atomic orbital combined to give you molecular orbitals, right? Yes, so here is the definition for molecular orbital. In a molecule, if the electrons are present in a new orbital, then it is known as a molecular orbital, right? Okay, and now we came to know what is molecular orbital and what are the postulates. So we just simply said atomic orbitals will undergo the combinations on their own, but whenever the atomic orbitals undergo combinations, we need to keep in mind that the orbitals will undergo combination only if they have the equal energy or comparable energy. Okay, so when we look into the first postulate, atomic orbitals with equal energy or comparable energy will undergo combinations, so that when they undergo combination, one more thing we can expect. So what we can expect is, how about the shape of the molecular orbitals? The shape of the molecular orbitals will be determined by the combination of atomic orbitals, what shape it is. That means that what shape that atomic orbital has, the same shape will be expected for the molecular orbital also, right? Okay, then when we look into the second postulates, when two atomic orbitals combine we get two molecular orbitals. That means that how much ever atomic orbitals undergo combination, you get so many molecular orbitals, right? So for example, when two atomic orbitals combine to give you two molecular orbitals, so the obtained two molecular orbitals, know what how it will be is, one will be having lower energy, another one will be having higher energy. Okay, the two molecular orbitals formed, one will be having lower energy, another one will be having higher energy. Okay, so how to name that lower energy molecular orbital? The lower energy molecular orbital is being known as bonding molecular orbital. The lower energy molecular orbital is known as bonding molecular orbital, and it's expressed by the letter n suffix b, right? And the higher energy orbitals is being called as anti-bonding molecular orbital. Anti-bonding molecular orbital, it is represented by Na. So these are the two important energy difference we need to find out. And generally how this bonding and anti-bonding is represented, that comes an important factor. So bonding molecular orbitals are represented by the terms called as sigmas, pi's and deltas. Got it? Bonding molecular orbital, how do they represent? They are being represented either by sigma or by pi or deltas. And anti-bonding molecular orbitals are represented as stars, that is sigma star, pi star and delta stars. So this is the mild difference between bonding and anti-bonding. So anti-bonding will carry star on the superscript. Got it? Yes. So now as the orbitals undergo combination we get molecular orbitals. And how do the electrons have been filled in the orbitals? So electrons are filled in these orbitals by following three major principles. Number one, Pauli's exclusion principle. Second one is Hund's rule, and third one will be Aufbau's principle. So Pauli's exclusion principle, we normally know that the electrons, how does the electrons will be. So electrons normally it should be in opposite direction. So two electrons whatever we use, generally it will be in the opposite direction. Okay, got it? So one will be facing upward, another one will be facing downward. That is, one is moving in the clockwise, another one is moving in the anti-clockwise direction. So that is the Pauli's exclusion principle. Hund's rule means equal pairing of orbitals should take place. So what is that equal pairing? So equal pairing in the sense, we have three boxes, that is three orbitals. Each orbital has a capacity of 2. So first equally electrons have been filled like this, 1, 2 and 3. Then only we have to fill the fourth electron, fifth and sixth electron. So this is only Hund's rule. And Aufbau's principle is nothing but increasing order of energy levels. So the lower energy, from lower energy only will begin to undergo combination. So